Day 2 in section 9.2, we're still talking about characteristics of quadratic functions. So by the end of this lesson, we're going to be able to graph a quadratic function without using a table of values. Based on a lot of the things that we've learned, we're going to kind of put it all together. So you don't need to write any of this down, but let's just refresh our memory about some things from the previous 2 lessons. Remember that a quadratic function, when graphed, is a U-shaped parabola. So every time you create a graph of a quadratic function, and think about what quadratic functions look like as far as the equation, they should all be U-shaped parabolas. Standard form of a parabola is y equals ax squared plus bx plus c. Remember that a parabola opens upwards if a is greater than 0, and a parabola will open downwards if a is less than 0. Remember that a is the coefficient in front of the x squared term, so that's where you should be looking. The vertex, it's the point of turnaround, and it's also where the max and the min occurs. And the axis of symmetry can be found using the formula x equals negative b over 2a. That's if we can't tell where it is on a graph or we don't have the graph. And then we can also use that axis of symmetry to help us find the vertex, because the axis of symmetry is the x value of the vertex. We can just plug that back into the function to find the y. So I've given you a lecture note sheet so that you've got a graph and you can make a good parabola on it. It should look very similar to what I have here in front of me. So we're going to graph the quadratic function. We also want to know the vertex, the axis of symmetry. We'll talk about what HP stands for in a moment. We want the max and the min, and we want the domain. So the first thing we want to find is the axis of symmetry. Remember, we're going to use our formula x equals negative b over 2a. So to find the axis of symmetry, I need to look at my coefficients. I want the opposite of b. b is a 4, so I want negative 4 over 2 times a, and my a is a negative 1. That gives me negative 4 over negative 2, which is positive 2. Remember that the axis of symmetry is a line, and you need to write it as an equation. You can't just write 2 on the blank. We need to say x equals 2. We also learned that that same x value is the x-coordinate of the vertex. So I know my vertex is going to be 2 comma something. Remember how you find the y-coordinate. We plug the 2 into the equation and we solve for y. So now to find the other half of the vertex, I'm going to take negative, or the opposite of 2 squared. Be very careful here with your sign. Remember, that's a negative 1 times x squared plus 4 times 2 plus 2. So for y, we get 2 squared is 4 times a negative 1 is negative 4 plus 8 plus 2, so that's 6. So the vertex is 2, 6. And I'm going to go ahead and plot that. 2, 6. The axis of symmetry, remember, is a vertical line. It's imaginary, that goes through the vertex. So my axis of symmetry is going to go like this. And I want those on the graph also. Even though they're not part of the actual function or the actual graph, we want to put it on there. Next, we can talk about a helper point. We can talk about max or min. We can even talk about domain and range at this point. But the easiest place to go from here is to a helper point. What a helper point means is you're going to pick any x value you want. You're going to plug that x value into the function again, similar to what we did here to find the y-coordinate of the vertex, so that we can find one other point that's on the quadratic function, or on the graph. The easiest point to pick is at when x is 0. Because when x is 0, this term goes away, this term goes away, and we get that y is 2. So now we can plot our helper point 0, 2. The only time you can't pick 0 as a helper point is if it's your vertex or your axis of symmetry goes through it. So then what we can do is, if you remember that the axis of symmetry actually splits a parabola into 2 symmetrical halves. So if we have this point at 0, 2, we're also going to have the mirror image of that point at 4, 2. Now, if you plugged a 4 into the function, you would get a 2 for x, or for y. Well, now we can basically draw the parabola. You need a maximum or a minimum of 3 points to graph a parabola, so long as the vertex is included. Remember, parabolas are U-shaped curves, so it would look something like this. You can also verify that it should be downward opening because the coefficient on x squared is negative. So now we need to talk about the max, the min, the domain, and the range. Here we have a maximum, we have a highest point on the graph. Remember, we use that y value of the vertex. So the maximum occurs at y equals 6. The domain for all parabolas is all reals. And the range, we use the maximum value or the minimum value. We're talking about all the values that are less than or equal to 6. So we were able to graph the parabola. We found the vertex, the axis of symmetry, stated whether it was a max or min. We stated the domain and the range, all without making a table of values. Let's look at another example. Number 2, we have x squared minus 4. So again, the first thing we want to do is find the axis of symmetry. Remember, it's negative b over 2a. So that's going to be x equals, and we don't have an x term here, and that's okay. So b is 0 over 2 times 1, which is 0 over 2, or 0. So our axis of symmetry is x equals 0. Our vertex then is going to be 0, comma, some number. We get that by plugging the 0 in. So we plug the 0 in for x. 0 squared minus 4, that's negative 4. So our vertex is at 0, negative 4. You can go ahead and plot that, and you can draw in the axis of symmetry. The axis of symmetry is a line that goes through x equals 0. Remember, it's vertical. It's also dotted because it's imaginary. So here's our first case where we can't actually pick 0 as our helper point, even though it's the easiest one to pick, but you can still pick any other easy value. 1 comes to mind as being the next easiest number to pick. So if I plug in a 1 to the function, remember I'm trying to find a helper point so that I can also find its mirror image so I can graph the parabola. So we plug in a 1, we get y equals 1 squared minus 4. 1 squared is 1. Minus 4 is negative 3. So our helper point is 1, negative 3. So if I graph 1, negative 3, I'm down here. Remember that the helper point is going to have another point who is its mirror image across the axis of symmetry. Another easy way to find that is to just count how many units over to the axis of symmetry. So it's 1 unit over. So if I go 1 more unit the other direction, there's my helper point. And here's your parabola. Whoops. And here's your parabola. Again, remember to make it as U-shaped as possible. So my helper point, my other helper point was negative 1, 3. And I'd like you to label both helper points that you use. We have a minimum value here. We have a lowest point on the graph. And remember, again, it occurs at the y coordinate of the vertex. So that's at y equals negative 4. It's the lowest point on the graph. From here, from this y value, everything else goes up. Our domain is all reals. And the range, again, we use this same negative 4 value, except here, the graph at negative 4, we're talking about negative 4 and everything above negative 4. So it's y is greater than or equal to negative 4. Another example, y equals x squared minus 2x. So what we have here again is axis of symmetry, so x is equal to negative b over 2a. Since b is negative, when we take the negative of a negative, we get a positive, so 2 over 2 or 1. So our axis of symmetry is x equals 1. It's also the x coordinate of the vertex. Now I'm going to plug that 1 in. 1 squared minus 2 times 1. 1 minus 2 is negative 1, so we get a vertex of 1, negative 1. So we can go ahead and graph that. There's your vertex, and our axis of symmetry is a vertical line. It's imaginary, so it's dotted, and it goes through the vertex. Now we want to pick a helper point. Because we aren't going through 0, 0, or we're not going through 0 on the x-axis, then we can pick 0 as our helper point. When we plug a 0 in, if I plug 0 in for x, I'm going to get 0 for y. So my first helper point is 0, 0. That means I have another helper point at 2, 0. Remember, count 1 unit over to the axis of symmetry, then count another unit over to your second helper point, or to that first helper point's mirror image. So now we can draw the parabola. Should be opening upwards because the coefficient in front of x squared is a positive 1. We have a minimum value, and it's down here at y equals negative 1. Our domain is all reals, and our range is y is greater than or equal to negative 1. Because it opens upward, remember this graph continues on in the positive direction, so we're talking about all the y values greater than or equal to negative 1. So now we've done 3 examples. I'd like you to try this next one on your own. So pause the video, see if you can find the axis of symmetry, the vertex, 2 helper points, draw your parabola, state if it's a max or min, tell me where it's occurring, and state the domain and the range. Then check your answer with me. So for axis of symmetry, we have negative b over 2a. That's negative 1 over negative 6, which is 1/6. And this one's going to be ugly because it's a fraction. So we get an axis of symmetry of x equals 1/6. That means that 1/6 is the x coordinate of our vertex. So now what we want to do is plug in 1/6. So we have y equals negative 3. In parentheses, we have 1/6 squared plus 1/6 plus 1. And this is about to get really ugly. If some of you get this, that's pretty impressive. So we have to square 1 over 6. That's 1/36. And now we have to multiply it by 3. When you do that, you get a negative 1/12 plus 1/6 plus 1. Now in order to add all these fractions, technically we need a common denominator. So negative 1/12 plus 2/12 plus 12/12. So negative 1 plus 2 is 1 plus 12. So we get 13/12, or 1 1/12. And you can write it either way. We're definitely going to have to do some estimating because this fraction is so small, it's going to be hard to find a 12th spot in between 2 numbers. But so we have 1 1/12. So 1/6, 1 1/12. That's going to be here. Oops. It's going to be right about there. So it's 1/6 over and 1 1/12 up. That's where your axis of symmetry goes through. You may ask yourself at this point if we have an opening upward or downward parabola. Hopefully you're saying downward. We can use 0 as a helper point. Since we don't go through 0, it's going to keep it pretty squished together, but that's okay. So if we plug in a 0, this goes away and this goes away, and we get 1. So 0, 1 is our helper point. That means we also have another helper point And you have to be careful here. Think that we are 1/6 away from the axis of symmetry, so you need to go 1/6 in the other direction. And I can zoom in on this so you can see what I'm doing. You have to go 1/6 in the other direction, so the other helper point would be 2/6, 1. And there's your parabola. Now I'll tell you now that there probably won't be anything this complicated that you'll see on a homework, a quiz, or a test, but I guess it's good practice with working with fractions. We have a maximum that's occurring at our at the y value of the vertex, so that's y equals 1 and 1/12. Our domain is all reals. And our range is y is less than or equal to 1 and 1/12. Now hopefully my math checks out over there on the left hand side, and then it was in fact 1 and 1/12, but I'm sure you'll let me know if I was wrong. If you got this, that is pretty impressive. If you didn't, hopefully you can try to figure out or understand where you went wrong, but let's go on to another one, try one more on our own. Hopefully this next one's a little easier. So we have y minus 2x squared equals negative 12x plus 7. And before you pause the video here, I just want to point out that you need to make sure this equation is solved for y first. So we need to add that 2x squared to the other side. So that's going to give us y equals 2x squared minus 12x plus 7. And so from here, go ahead and pause the video and try to fill everything out over on the right hand side. So over the axis of symmetry, we have x equals negative b over 2a. That's 12 over 4, or 3. So our axis of symmetry is x equals 3. Remember, it's also the x coordinate of the vertex. Plugging the 3 into the original equation, we want to use this one here where we have it solved for y. 2 times 3 squared minus 12 times 3 plus 7. It's going to give us 18 minus 36 plus 7. And that's negative 11. So our vertex is at 3, negative 11, which now we're going to see is off the graph. I'm going to move mine up just a second. Okay, so I've moved my graph up so that I can at least get to my vertex. But I'm going to go over 3 and down 11, 9, 10, 11. So we're roughly right here. Here's my axis of symmetry through x equals 3. And although initially it looks like it might be a downward facing parabola because the 2 is negative, when you solve it for x and put it, or solve it for y and put it in standard form, the coefficient is actually positive now. So we do have an upward facing parabola. My helper point, I'm going to plug in 0. So when I plug in 0, all of this goes away and I get a 7 for y. So 0, 7. I'm 1, 2, 3 units away from the axis of symmetry, so my mirror point is going to be 1, 2, 3 units away the other way from the axis of symmetry. So now you can see this parabola is a very skinny parabola. And we want to make it look as U-shaped as possible. And so then my other helper point was at 6, 7. We have a minimum, and it's occurring at y equals negative 11. It's the lowest point on the graph, way down here. The domain is all reals. And our range is y is greater than or equal to negative 11. Because we're opening upward, the graph continues upward, so we're talking about all the y values that are greater than or equal to negative 11. So hopefully this is starting to make sense now. I do think it's easier than finding or calculating a full table of values, especially since sometimes we can't find the vertex, so then we're not sure which way our parabola goes. There's one more example here. I would like you to try this one on your own, and I'll check for it in your notes. If you get it right, I'll give you a little bit of bonus. So number 6 does need to be completed. Fill everything out on the right hand side, and I'll actually be collecting your note sheets when you come to class before I pass out the worksheet. So are you able to now graph the quadratic without a table of values? Those were all the examples we did today, 1 through 6. And in class we'll work on worksheet 9-2B.